Excel Year 1 Maths Pearson Textbook Chapter 14 Section 14.4 Logarithms, the beginning. So this is an introduction to what logarithms are and how they link to exponential functions so that you can see why we have them and what they're for and how we can use them. And to start with, I want you to think about if I said to you, and I am going to take you back to primary school, yes, but I need to get you thinking, x add 3 equals 10, you would go, I use the inverse function to find x, and I would take away 3. So adding 3 is the function, taking away 3 is the inverse function. It gets you back to find what x is. And you can do this with anything, can't you? So if I do x multiplied by 5 is 10, and I said to you, what's the inverse function? You would say to me, that's dividing by 5. And then you get yourself to secondary school and we say to you, 5 squared is 25. And then we ask you what the inverse function is. So if I gave you 25 and I said to you, and I have squared a number, so if I wrote it like this, I've squared a number and my answer is 25. Can you tell me what the number is? You would say, I need to square root. You'd obviously have to do the plus or minus because you wouldn't know whether it's positive or negative. But you know that if a function's been squared, to get back to that original value, you would square root is the inverse function. So, if I say to you that 3 to the x equals 9, what's x equal to? Well, I imagine you're all saying squared. It's 3 squared, so x is 2. Not x is squared, but x is equal to 2. But how would I do that if it was 3 to the power of x is 10? Yeah, that's not going to be as easy. And actually, at the moment, all you have is trial and improvement. You wouldn't have a clear method. So we know how to find the exponential, but we don't know the inverse function. You've never done it. We've kind of just hidden it from you. You're fine when you're here, and you've got to find here, which is like your base number. But when you don't know what the exponent is, you have no inverse function to find that out. And that's what logarithms are about. Logarithms will help us find this out. It's the inverse function. So there's the exponential, and the inverse function is the logarithm, and they match together, just like squaring and square rooting, multiplying and dividing, adding and subtracting. So this is what we're going to learn about today, is logarithms. And I want you to clearly understand their link with exponential functions. So let's look at our first example. We're going to go back to that 3 squared equals 9. And I'm going to write it in a different format, and then I am going to speak it because this is logs. And this is the stage where you need to understand the link between them. So we would say this in words the following way. The logarithm of 9 to the base 3 is equal to 2. So say that again. Logarithm of 9 to the base 3 equals 2. And if we think about this, we can change this, and if it was 3 to the x equals 9, log to the base 3 of 9 would equal x. And we would be able to find what x is, what that exponent actually is, which up to now in maths, you've never been asked that question other than via a trial and improvement method. And now you can find the exact value if you use your calculator as well. Okay, so I'm going to do another one now, and I'm going to do one so you can use your calculator, and I'm just going to explain something about your calculator at the same time. So 10 to the power x equals 1000. Now I hope you can guess what x is at this point, but using what we know from the example that I've done before, what we can write here is the log of 1000 to the base 10 is equal to, and I hope you're going to say 3 because you've realised that 10 cubed is 100,000. Sorry, 1,000, not 100,000. Now, when you're doing this on a calculator, if you get your calculator in front of you now, so you might want to pause it, run off, get your calculator, come back. On your calculator, you'll usually find a button that says log, L-O-G, and you'll usually see a button that says ln, or it might actually look a little bit like in. It's not in, it's ln. Often I hear students call this lun. I've even taught to students that have called it lin, but it's the natural log. So you have log, log, and ln, which is the natural log. Now I'm going to talk about log to start with. On your calculator, this is the base 10. So that log there is for base 10. So if you find the log button on your calculator now, so you're looking for log on your calculator, and if you press that and then type in 1000, you'll get the answer 3. So that's by typing in that using the log button, log. Now you're going to say to me, but what about this here, log when the base is 3? Now some calculators can do this as well, and you would need to look at your calculator and what it's capable of doing. But all calculators can do the base 10 log, and remember this number here is your base. So that's here base 10, this one was base 3. So all calculators with the log button, that is saying they're using base 10. And you will also find on your calculator, as I just said previously, the ln button, and this is the natural log button. So if I give you an example for this one, it would be e to the x equals, and we'll choose a value, maybe 3, and using what I know before, the log, and remember, this here is my base. This here is my base. So here e is my base. So it's log to the base e of 3 equals x. Because remember, logarithms allow us to find that exponent. So log e. Now log e on our calculator is the ln button. So if you then type that into your calculator, I'm hoping you'll get the answer 1.09861 and so on. Really all I'm trying to get across to you on this set of work is that when you are finding the exponent, this number here that you have raised to a power, this number here, the 3 is your base, and your answer, we would say log of 9 to the base 3 is x. And here it's log of 10, so that's our base, of 1,000, which is our answer here, equals, and it's 3, but that is our x. Okay, so we've just worked out what x is. And the other thing that I want you to get from here is that log on a calculator is base 10. And ln, which I know it says in on your calculator, but it's ln, that's the natural log, and our base is e. And if you can't remember what e is, you need to go back and look at a different video. Right, we're going to move on and do some more examples now. So I am going to now look at the textbook. Remember, we're looking at section 14.4 logarithms, and we're going to look at example 6. I've already actually touched on example 6. So a 3 squared equals 9, and you're asked to write each statement as a logarithm. So what you're asked to do is write these as a logarithm. So here this would be log, what would my base be? My base would be 3. So log of 9 to the base 3. Remember 9 was the answer, and that would equal 2. B, 2 to the 7. I've now got to write equals 128. So log, what's my base going to be? So there's my base. So log to the base, and it's log base 2. So it's the log of 128 to the base 2, and that would equal the exponent, which is 7. C, 64 to the power of a half equals 8. So log, what's your base going to be? Can you guess what it's going to be? Yes, 64. And what am I doing the log of? I'm doing the log of 8 to the base 64 is equal to my exponent, a half. So we need to remember that this is our exponent, because what the logarithm is helping us to find out in these cases, the answer is the exponent. So that's example 6. Moving on, example 7. So here we're given, in example 7, you're given something in a logarithmic format, and you're asked now to write it using a power or an exponent. So log to the base 3, this is, so log 81 base 3 equals 4. So the base is the number that goes first. This here is my exponent, which is 4, and that must equal 81. So remember, the base is this number here, and this is my exponent, which is my answer in a log. Okay, B. If I write B out, maybe you press pause. Can you write it in the new format? Press pause, have a go, press play when you think you know what it is. Okay, so I start with, what is my base? My base is 2. What is my exponent? It's -3, and my answer is 1/8. Now, we can see 3 to the power 4 from this one is 81. 2 to the -3, 2 to the power of -3 is 1/8, because 2 cubed is 8. So 2 to the -3 is 1/8. So I'm hoping that's all making sense to you. And we can now move on and have a go at example 4. And this is using a calculator. Now, you need to go and investigate your calculator at this point and understand how to work it so that you are able to do these questions. So, you need to go and find out how or where is this button on your calculator. Because this button here, and by the way, it may be in a menu, you might have to look it up in options if you've got a Casio calculator. This will allow you to put any base in, because remember, I was speaking about your calculator earlier. The log button is base 10, ln is the natural logarithm, and its base is e. So I press pause now. Go off and find that button on your calculator. Okay, so going through the questions here, log to the base 3 of 81. So if you've managed to find this function on your calculator, you would put the 3 here, you would put the 81 there, and you could work it out on your calculator. But this question actually says to you you've got to do it without using a calculator. And this is, by the way, example 8 we're doing here. So to do it without a calculator, what you need to do is rewrite this in a format that might help you. So if you do this, you can say, well, 3 to the power of is my base, because remember that, to the power of whatever the answer is equal to 81. And if you work that out by doing 3 times 3 times 3 times 3, you should get to 81. So let's do that. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So the answer for this question would be 4. Okay, so log of 81 to the base 3 is 4 because my exponent is 4. You can check that on your calculator using this here. Now B, log to the base 4 of 0.25. Now if I'm doing this without a calculator, I need fractions because they make my life so much easier. So here I'm going to rewrite that as log to the base 4 of 1/4. So what's my base? My base is 4. I don't know what my exponent is, but I know my answer is 1/4. This is the reciprocal, so I know that the answer for this of log to the base 4 of 0.25 is -1, because when the exponent is -1, when I raise anything to the power of -1, I get the reciprocal, and the reciprocal of 4 is 1/4. So C, keeping going. C is the log of log of 4 to the base 0.5 is what I'm working out. Again, I'm going to write this in terms of fractions. I'm never sure whether it's going to help, but it helps me, I often find. So I'm doing a half to the power of something is 4. Well, I know that a half squared is a quarter, and I know the reciprocal of a quarter is 4. So I know that that is going to be -2, because again, a half squared is a quarter, and negative power, negative exponent, that's the reciprocal, so the quarter would turn into a 4. And D is log of a to the 5 to the base a. So I'm saying here my base is a, and this, so a to a certain power is equal to a to the 5. So what would that be? It would be 5. Now, they're worth going back over and rethinking about and checking you fully understand them. Question 9 asks you to do some questions with a calculator. Now, I would suggest that we've actually already covered this, and here if you'd have typed this in your calculator and checked that you could get 4 for this one and do the same for this one here, you would be able to miss out example 9 and get straight on with the exercise. It does say in example 9, write your answer to 3 decimal places, and if I'm honest, that's the most common error, is people don't write it to the correct number of decimal places. Okay, so off you go. If you're using the textbook for Pearson, which is a really good textbook, it's now off you go with exercise 14D.